Assalamualaikum warahmatullahi wabarakatuh. Good morning to everyone. My name is M.N.R bin Abu Bakar and I will present about sustainable concrete solution utilizing palm oil fuel ash and Metakaolin in coconut shell aggregate lightweight concrete. LWC stand for lightweight concrete, increasingly being utilized in numerous applications such as heat insulation and energy efficient walls. LWC also reducing the overall mass of the structures, reduce the seismic load and leads to the significant cost savings in construction materials. Having higher strength to weight ratio, a reduced coefficient of thermal conductivity and enhanced durability properties. Next, coconut shells also have the potential to replace the traditional aggregate and act as the lightweight concrete in concrete production. Therefore, coconut shell has been utilized as alternative for natural aggregates in construction materials. In this study, POFA and Metakaolin is used as a partial cement replacement, as POFA is a solid waste produced from palm oil mill manufacturing process. POFA is also listed as one of the pozzolanic materials which is suitable for partial cement replacement. Pozzolanic reaction will improve the strength and microstructural features at later age. This is due to the POFA that is rich with silica content. Metakaolin is an initiative for cement replacement. Metakaolin yields aluminosilicate and it is also listed as reactive natural pozzolan. Concrete ideal strength achieved ranging from 10 to 20% using Metakaolin as a cement replacement. For coconut shell, it is other alternative. It is potential to replace traditional and natural aggregate, act as a lightweight aggregate in concrete. So coconut shell is compatible with cement, improve the impact resistant compared to the traditional aggregate. This information is according to the Iscee 2022. So this is the methodology process. For ordinary Portland cement, the cement content used is 95%, 90%, 85% and 80%, which is I will replace it with POFA. As we can see in the slide, I collect the POFA and oven dry, grinding POFA using the ball mill, sieve POFA at 7 type, and lastly passing through the 75 micron. The POFA content that used is 5%, 10%, 15% and 20% as a cement replacement. For Metakaolin, the percentage of Metakaolin used is 10% fixed. For fine aggregate, 100% used and used directly. For coarse aggregate, we will go the process passing through the 10 mm and retain at 5 mm. The percentage of coarse aggregate used is 50% because the other 50% will be replaced with coconut shell, which is crushed coconut shell passing through the 14 mm. So this is the design mix. P0 is a 0% of POFA, P5 is 5% of POFA as a cement replacement, and a P10 is a 10%, P15 is 15%, and lastly is P20 is 20%. For P0 is 0 kg of POFA, P5 5% of POFA is 20 kg of POFA. This table is for 1 kg per meter cube. For coarse aggregate, use is 50%, which is 565 kg per meter cube, and coconut shell use is 50%, which is 270 kg per meter cube. This is the testing series, starting with the density, compressive strength, flexural strength, split tensile strength, and lastly the water absorption. This is the total of the sample for the testing series. So this is the result for the slump test. The highest slump test is recorded is 55 mm and belong to the P0, which is 0% of POFA replacement. And the lowest slump is recorded as 39 mm and it belongs to the P20, which is the highest replacement of POFA, 20%. So consistent decrease pattern as shown in the graph as POFA content increases. So the POFA content increase will reduce the workability of concrete. This is due to the significant amount of unburned carbon that will absorb water and will reduce the workability. So this is the result of density of concrete for each mixes. So the highest density is belong to the P5, which is used 5% of POFA as partial cement replacement. For the coconut shell as a partial replacement for coarse aggregate will reduce the overall density of the concrete. Density of LWC with POFA substitution aligns with the acceptable range for LWC, which is below or equal to the 2,200 kg per meter cube. The effectiveness of POFA, which facilitates the chemical reaction, which is known as pozzolanic reaction, promote the formation of calcium silicate hydrate gel, enhancing the concrete density. So the pozzolanic reaction reduce the voids, also increase the dry density of concrete. But too much POFA will reduce the dry density because it is porous particle absorb more water and making it harder to compact. And for the poor, if the compaction is poor, will lead to the honeycomb-like voids in the concrete, resulting in a porous structure and lower dry density. So this is the result for the compressive strength. We can see that the highest compressive strength at 7 days is belong to the P5, which 69.64% increment from the P0. Lightweight concrete plus POFA will increase the strength compared to the lightweight concrete without POFA. So the P5 is the highest compressive strength at 5%, but the strength will decrease when the POFA content is increased. The density is also belong to the P5 with the 1,990 kg per meter cube, which is the highest density at 5, but the density will start to decrease when the POFA content is more than 5%. The pattern shows in the graph, and the coconut shell will decrease the weight and also will decrease the strength. Same goes to the 28 days. The same pattern is recorded. The highest compressive strength is recorded at P5 with the increment of 68.55% from the P0. The Metakaolin enhanced the early strength with the pozzolanic reaction, which is ranging from 10 to 20% of partial cement replacement. And the highest density is also at the P5. So this is due to the coconut shell as a partial coarse aggregate replacement in LWC decreased the compressive strength with a 50% substitution, resulting in a significant strength reduction due to the poor bonding between the coconut shell and the cement paste. The POFA in lightweight concrete enhances the strength as much as 5% of POFA replacement. This is due to the additional CSH gel formation from the pozzolanic reaction. By replacing more than 5% of cement with POFA will reduce the compressive strength because POFA's porous nature makes the mix harder to compact, creating more voids. So next is the flexural strength. At 7 days, the highest flexural strength is recorded at P5 also. 5% of POFA as a partial cement replacement with a 56.49% increment from the P0. So the 5% of POFA yields the highest flexural strength, but when the POFA content is increased beyond 5%, the flexural strength will also decrease. This pattern is shown in the graph. And for the density at 7 days, it belongs to the P5 also with a 1,990 kg per meter cube. And again, the coconut shell replacement will decrease the flexural strength. Same pattern is shown at 28 days, which the highest flexural strength is recorded at P5 with a 39.29% increment from the P0. So this is for the 5% of POFA yields the highest flexural strength. The strength is occur because of the maturation process, which is improved the strength, which is from 7 days to 28 days. And the highest density is also recorded at P5 with a 2,040 kg per meter cube. So POFA will fill the gaps and voids, create dense microstructure particle contact. And for the Metakaolin, incorporating Metakaolin into recycled coarse aggregate will improve the splitting tensile strength compressive strength, and a flexural strength. So next is the split tensile result. Same goes to the compressive strength and flexural strength. The highest split tensile strength is belong to the P5 with a 5% of POFA as a partial semi replacement with a 6.02%, which is the highest increment compared to the P node. So the lightweight concrete plus POFA will increase the strength compared to the without POFA. So the P5 is the highest tensile strength at 5%, but the strength is start to decrease when the POFA content is start to increase more than 5%. For the density for 7 days also belong to the P5. So according to Iscee 2022, the coconut shell will decrease the weight, but also decrease the strength, which is 50% of replacement. For 28 days, the same pattern is recorded, and the highest split tensile strength is recorded at P5, which is 32.18% increment from the P node. So the trend is enhance the split tensile strength for POFA mixes. So when POFA using POFA in the lightweight concrete will increase the tensile strength, particularly lower than the lower replacement, which is 5% of POFA. So the density is also P5 for 28 days, which is the POFA will improve the both early and long-term split tensile strength. Because of according to the Thomas, that discovered that the concrete samples containing 10 until 20% of POFA exhibit the higher tensile strength compared to the control specimens over a 90-day period, with a trend similar to the compressive strength of control OPC concrete. The M.N.R is also determined that the optimum strength in concrete required the inclusion of Metakaolin and POFA at concentration ranging from 10% to 15% and 10% to 20% respectively. According to Aziz, found that adding coconut shell aggregate to regular concrete decrease the compressive strength, splitting tensile strength, and the flexural strength. So this is the water absorption result for 7 and 28 days. The lowest water absorption is recorded at P5 for both 7 and 28 days. P5 exhibits the lowest water absorption, and while for the P20 exhibits the highest water absorption. As we can see from the graph, the water absorption at 28 days, the record is 3.75% of the water absorption. As we can see from the graph, the longer water curing times, the decreased water absorption. This is due to the pozzolanic materials, which is POFA and Metakaolin. When the POFA content is increased, the water absorption is also increased. This is due to the unburned carbon. For the density, still belong to the P5 with the highest density at 1,1990 kg per meter cube for 7 days and 2,040 kg per meter cube for 28 days. The coconut shell replacement will decrease the porosity after 28 days. This is due to the secondary hydration process. While for the Metakaolin, water absorption is not exceeding 10% of replacement, which is higher durability. Next, this is due to the incorporating Metakaolin into the recycle cost aggregate will improve the splitting tensile strength, compressive strength, and flexural strength. From this study, we can conclude that for overall, P5 attributed to the highest compressive strength, flexural, and split tensile strength at both 7 and 28 days. This is due to the pozzolanic reaction by POFA and MK, resulting in increased CSH gel formation and concrete density. Next, this is due to the pozzolanic reaction by POFA and MK, which is increase in CSH gel formation and concrete density. And a P5 has the lowest water absorption percentage and decreasing due to the increase of POFA content. For coconut shell, act as a partial cost aggregate replacement, successfully produce lightweight concrete within the desired density range of 2,200 kg per meter cube according to the EN guidelines. That's all from me. Thank you.